Today we're going to learn about multiplexers, decoders and programmable logic device. So what is a multiplexer? A multiplexer has a group of data inputs and a group of control inputs. Let's draw a 4:1 multiplexer. So 4:1 multiplexer will have 4 inputs, 2 control inputs, which is A and B. Let's make this I0, I1, I2 and I3, and Z is the output. So depending on the control input, the particular input will be transmitted at the output. So if A and B is 0 0, I0 will be transmitted, 0 1, I1 will be transmitted, I2 will be transmitted, and 1 1, I3 will be transmitted. Okay, you can write this as a Boolean expression also. So the Boolean expression for this would be A bar B bar I naught plus A bar B I1 plus AB bar I2 plus AB I3. So we can write for a 2:n mask as 2:1 to 1 marks as 2:n inputs. This is like 2:n data inputs. It will have n control inputs and 1 output, Z. Yeah, so you can write this as Z equal to sigma k equal to 0, 2:n minus 1, mk ik, where mk is the mean term of n control variables with ik corresponding data input. So you can draw this 4:1 mask with AND and OR gate. So it will be 3 input AND gate, sum up to an OR gate. Okay, so the input should be A bar B bar I naught, A bar B I1, A bar AB bar I2 and AB I3. So this is how you will design a multiplexer with AND and OR gate. So now let's look at a decoder. So let's look at a 2:4 decoder. So 2:4 means it has 4 outputs and 2 inputs. So basically decoder generates the mean terms y0, let's say y1, y2 and y3. Let's say the inputs are A and B. So the truth table for this would be okay. So the truth table for this would be, if the input is 0 0, the output y0 will be 1, rest of them are 0. 0 1 will make only this one, y1 1, and rest of them 0. Similarly here this one and 0 1 1, 0 0 0 1. Okay, now this is called an active high output. Suppose if you are asked for if the output is active low, then the same thing you will write, but you will add a bubble here. So this, the truth table for this would be so this will become for 0 0, first output will be 0, rest of them will be 1. Second y1 will be 0, rest would be 1. For this it would be y3, and for this y4. So suppose you are given a function f, let's say with m0 plus m1 plus m4 plus m7, and you have to implement it using NAND gates and use active low decoder output. So basically the one which is shown here, y0 y1 with the bubble. So how you will draw it is, you will take a b c and you will take 3:8 decoder, and first you will use De Morgan's theorem and convert it into a NAND gate implementation as shown here, m0 m4 m7 bar, and then everyone would be you will just connect all the four outputs m0 m1 m4 m7 to the NAND gate as shown in the figure below. So now let's discuss ROM. ROM is called, the full form of is read only memory. So basically it is used to store an array of binary data. Once the binary data is stored, you cannot change it under normal operating condition. You can change it using ultraviolet rays or through electrically programmable. So there are many versions of ROM which you can use to change the data, but under normal operating condition you cannot change the value that is stored in the ROM. So ROM is basically a decoder with a memory array. So if you use this memory array, so if there are n input lines, so the size of the array would be depending on number of output lines. So let's say there are m bits stored, so the output would be m bits. There will be m output, right, and total number of rows would be equal to 2 raised to n. So this will become 2 raised to n by m bits memory array size. So suppose you are given two functions, let's say f naught is equal to a bar b bar plus ac bar, and f1 equal to a bar b bar plus bc bar, and you need to implement this function like a sum of product function using a ROM array. So how you will do it? So basically you'll draw a decoder, and this is like a 3:8 decoder with 3 input ABC and output M0, M1, M2, M3, M4, M5, M6, M7. Okay, so you can rewrite this function as A bar, B bar, C bar plus A bar, B bar, C plus A, B bar, C bar plus A, B, C bar. Okay, so if I see this is 0, this is 1, this is 4, and this is 6. So this will become sigma m 0146. Okay, and this will become, let me write this again, A bar, B bar plus BC bar. So this is again same, A bar, B bar, C bar plus A bar, B bar, C, and I'll write A, B, C bar plus A bar, B, C bar. So this will become, this is 0, this is 1, this is 6, and this is 0102. So this will become sigma m 0126. So now let me represent this using rhombus array. So this would, let me take a little bit down. Okay, so now let me, so I can write this as, so I can use an OR get array to sum up all the F0, F1. So this will be F0, suppose, and this will be F1. So you will mark whatever is used in F0. 0146 is used, so I'll use 0146, and 0126 is used, so 0, 1, 2, and 6. Yeah, so this is how you can represent and an expression into a ROM array. Using the ROM array, you can represent any Boolean expression. So now let's go to programmable logic array. So basically ROM is just a decoder with an OR array. So if you want to represent any sum of product expression, you can use this. This will become a ROM. But if I replace this decoder with an AND array and this goes to an OR array. This becomes programmable logic array. So we are replacing decoder with an AND array. And so let's see how do I represent the same F0 and F1 using AND array. So we'll use A, B, C 1 and we'll use A bar. So this would be A, this would be B, and this would be C. So the expression is A bar B bar plus AC bar. So I'll take A bar B bar, I will AND it and give that as the output. What's the next? AC bar. So A C bar, I'll give this as the output. This is A bar B bar, this is A C bar, and we need B C bar. So I just use this 3-1. So B C bar will give me the third term that we are using. Now we can use an OR array to get the required output. So this would be F0, this would be F1. So I would OR F0 F1. So for this, A bar B bar plus AC bar. So I would OR this term and this term and this term and this term for F1 and F2. Now suppose you are asked a question to realize a function, let's say ABC is equal to, let's say, M0 plus M1 plus M4 plus M7. Okay, so you need to realize this function using NAND gates and a decoder. So how will you make this? Using NAND gates, and let's use an active low decoder. So basically the output is active low decoder output. So how would you realize this function? So you will, since there are 3 input variables A, B, C, so it's a 3:8 decoder. There are 8 possible outputs. So basically 3, so n raised to 2 raised to n outputs. So you write M0, M1, M2, M3, M4, M5, M6 and M7. These are all mean terms that you can realize. So basically this function is, you can write it as, so let's make M0, you can rewrite this function, you can rewrite this function as M0 plus M1 plus M4 plus M7. Let's make it Z is equal to this. You can use De Morgan's theorem and write the same function as like this. M1, M4, M7, bar, 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 bar. So basically These are all active low outputs you get from here, and you can directly connect this to NAND gate M0, M1, M4 and M7. This is your Z output. So the difference between PLA and the ROM is that ROM implements a truth table, just like this. Could be a truth table, while PLA implements the sum of product expression, basically A bar plus B bar, F0 and F1. Basically it will just implement this. While this ROM table, you need to convert it into a particular address line like 0146 and then implement it. Suppose you are asked to realize F1 and F2 using PLA, and draw the diagram for this and draw the PLA table. So how would you approach this? So I'm going to show you how to solve this problem. So basically you first simplify the expression using K-map. So let's do that first. A, B, C, D, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So all the ones are, so let's write down the one. So 1, 1. So this is for F1. So 4 as 1, 5 as 1, 6 as 1, 8, this is 0, 1, 10, 12 and 14. So 12 and 14. I'll write down all the 0. So F1 would be equal to, if I draw this is 1, so this will be CD bar plus, if I give this one as 1, this will form one loop which will be BD bar plus, this will form one loop which is AD bar plus, this will be one loop, this would be A bar, C bar, D. Similarly, we can write F2 as, let me do F2 here. Yeah, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 2, 4, 6, 8, 4, 6, 8, 10, 11, 12, 10, 11, 12, 14, 15. Okay, so this would be zeros and ones. So let me circle this. This F2 is equal to CD bar plus this is BD bar plus AD bar like this plus this will form one more loop which is AC. Now if you want to implement this with, let's do the PLA table first. So the PLA table would be, let me write A, B, C, D, and let me write down all the functions that we have. CD bar, BD bar, AD bar, and AC, and A bar, C bar, D. So this is the PLA table that you need to show if it's asked in the question. So yeah, whatever is CD bar, so this will be C will be 1, D bar means 0, this will be 2, you have to put dash there. Similarly dash D bar, this would be 1, dash dash 0, and AC would be this, and this would be 0 dash 0 1, and you can write F1 is equal to F2. So it has CD bar, F1 has CD bar, it has BD bar from here, AD bar and A bar CD. So AD bar and A bar CD. So just write once whichever terms are included in the expression. So CD bar is included, BD bar is included, AD bar, AC is included, and now you can complete this table. Now let's draw the diagram. So let's draw the PLA diagram. So this would be A, B, C, D with inverted for every A, B, C, and D. So let's write C D bar. So this would be C D bar. So just write cross here. Then comes B D bar. So B D bar. Cross here. Then comes AD bar, AD bar, then comes AC, AC, then A bar, C bar, D, A bar, C bar, D. Okay, and then you can just draw F1 and F2 from here, and you can just mark this ones. These are the OR gates. This is addition of CD bar, BD bar, sum of this AD bar and A bar, CD bar. Similarly, this would be sum of these terms. So this is how you solve a PLA diagram, and this is the PLA table. And if you are asked to do the ROM expression for, let's say, F1 and F2, you just have to take the decoder output from M0 to M16 or something, M15, and then just mark all the terms that is mentioned inside this 1 2 4 5 6 8 10 12 14. Just cross that will be your ROM table. Okay, ROM diagram. Okay, thank you.